Hey guys, quick video about when working with fractions, when verifying trig identities, using conjugates and least common denominators, how to recognize when you would use them and how to properly use them. So looking at this, I have the sum of two fractions, the denominators are different, and I'm trying to simplify this to the point that it becomes this, a single term, right? That means that these two fractions have to become one fraction. So the most direct way to do that is going to be to try to make a common denominator. Now, one way to make a common denominator with this would be to multiply this side by this denominator, so sine over sine, and this side by this denominator, so 1 minus cosine, 1 minus cosine. That could work, but it's going to get kind of messy. Using a conjugate, if you see something like this, 1 minus cosine, so it's like almost a Pythagorean identity, but not quite. If it were a Pythagorean identity, this would be really nice because 1 minus cosine squared is sine squared, right? And this side is already sine, so it's probably going to be, it would be easy to make this side have a denominator of sine squared. It's like halfway there. Okay, so enough rambling. Multiplying the conjugate. If you see 1 minus cosine, something like this, again, almost a Pythagorean identity. Multiply it by its conjugate on top and bottom. So 1 plus cosine on the top and bottom. What that's going to do, I can distribute the sine in, and it will be sine plus sine cosine. When you multiply this by its conjugate, 1 plus cosine and 1 minus cosine, that's a difference of squares. What's going to happen is it's going to end up being 1 minus cosine squared. If you FOIL this outer box method, multiply it, it's going to be 1. There's going to be some stuff in the middle that cancels out, and then you're going to have a minus cosine squared at the end. Okay, this side is still 1 minus cosine over sine. Pythagorean identity. So this is now sine plus sine cosine all over sine squared. Now there's a couple of ways to approach it at this point. I'm gonna make a common denominator. You could certainly start canceling out signs to make a common denominator on this side, but let's say for whatever reason we're not going to do that in this case. Just to use to make a common denominator, just to say we did. What I would do is I could look and say, okay, this side is sine, this side is sine squared. To make a common denominator, I have to make this side sine squared, and I can do that by multiplying the top and bottom by sine. That's allowed because sine over sine is 1, so I'm not changing the value of this, I'm just changing how it looks. And now I'm going to have sine plus sine cosine plus sine minus sine cosine. Oops. And it's all going to be over sine squared. And then you can simplify it further from there.